So a perpendicular bisector is a segment, ray, line, or plane that is perpendicular to a segment at its midpoint. How many perpendicular bisectors does a triangle have? Christina? 3. Very good. Those 3 perpendicular bisectors are what, Brendan? Okay, go ahead. Ask me a question. Yes, it creates a midpoint. Yes. Perpendicular bisectors create a midpoint and they're perpendicular. Now, how many perpendicular bisectors does a triangle have? Edmund? 3 perpendicular bisectors. Very good. And those 3 perpendicular bisectors are what? Andy? Concurrent. Very good. That means they form a what, Kara? A point of concurrency. Very good. What is the point of concurrency for the perpendicular bisectors of a triangle? Claire? The circumcenter. Very good. It is the circumcenter. What do we know about a perpendicular bisector? What else do we know about a perpendicular bisector? We studied this yesterday. We proved this yesterday. Sarah? Very good. Any point on a perpendicular bisector will be equidistant to the endpoints of the segment of which it bisects. So, if I have segment AC, and we have BD, and FG, HK, and you know that BD bisects, is a perpendicular bisector to AC, then what do we know about all those points on there? We know that BD perpendicularly bisects AC. So what do we know about all the points that I labeled up there? What do we know about all those points? Lauren? So give me the line segments that would be equidistant, even though they aren't up here. All right, AF and CF are equidistant. Tyler, what else is going to be equidistant? AG and GC, very good. These segments here are also equidistant. What else is equidistant? Edmund? AH, HC, then KA, KC, BA, BC, DA, DC. And however many points I want to put up there, they're all going to be equidistant to the 2 endpoints, right? So that theorem deals with the perpendicular bisector. So you have to know what a perpendicular bisector is, how many a triangle has, where they all intersect, at what point that's called, and then also the theorem regarding perpendicular bisectors. So we're building here. You have to know more and more about them. Okay, now, a circumcenter. Where does the circumcenter fall? Where does the circumcenter of a triangle fall? You know, before I ask that question, before I answer that question, turn in your notes, please, to the second page of 5.2, the second page of the section. We have some vocabulary I want to run through real quick before you answer that question. First, concurrent lines, rays, or segments. This is when 3 or more lines, rays, or segments intersect at the same point. Concurrent lines, rays, or segments. This is when 3 or more lines, rays, or segments intersect at the same point. And that point where they intersect, we call that a point of concurrency. This is the point where 3 or more lines, rays, or segments intersect. Now, going back to the question I asked, where does the circumcenter fall, Andy? Where three perpendicular bisectors meet. Very good. So circumcenter. This is the point of concurrency for the three perpendicular bisectors of a triangle. Point of concurrency for the three perpendicular bisectors of a triangle. Point of concurrency for the three perpendicular bisectors of a triangle. So in terms of a triangle, it's where the three perpendicular bisectors are going to meet. Now, something we haven't really talked about yet, but we're going to be here. The circumcenter is also the center of a circumscribed circle. The circumcenter is the center of a circumscribed circle. Now we're going to be I will define circumscribed circle for you here momentarily, later on this period. And a triangle has one circumcenter. So we have three perpendicular bisectors, one circumcenter. So Alexis, where does a circumcenter fall again? Center of a circumscribed circle, very good. Where else? What did Andy just tell us? That's what I want to go back to. Molly, where does the circumcenter fall? The point of concurrency of the, I'm sorry, what? Very good. It's the point of concurrency for the three perpendicular bisectors. Very good. Therefore, what type of line does a circumcenter fall on? What type of line? Don't overthink this. This is actually a very simple question given what Molly just told us. Keegan. What type of bisector? A perpendicular bisector. Very good. So if I go back to this picture that we had at the start of the section, this picture right here, and let's say I label this triangle A, B, C, and I take this point right here. That's where all three of them meet. That would be your circumcenter, and I label it P. So P falls on the purple perpendicular bisector up there, the blue perpendicular bisector, and the green perpendicular bisector. Now, let's take these one at a time. What does it mean if P falls on the purple perpendicular bisector? If P falls on this purple perpendicular bisector, what does that mean? What does that mean? Kara? It's equidistant to A and C. Very good. So that means that this here and this here are equidistant, right? Is everyone with me? Okay. Now, P also falls on the green perpendicular bisector. What does that mean? Maureen? It's equidistant from A and B. So A to B is the same distance. And P also falls on the blue perpendicular bisector. What does that mean? Claire? It's equidistant from B and C. And it's already up there, right? I already drew the dotted lines. So tell me, based on this information here, what do we now know about a circumcenter? What do we now know about a circumcenter? Lauren. To where? A circumcenter is equidistant from what? A circumcenter is equidistant from what, Pierce? All the what? What do we call those outside points? Vertices of the triangle. The circumcenter is equidistant from all of the vertices of the triangle. Turn to the very last theorem in this section, please. The third page of the section, theorem 5.4. We're going to change the name of that theorem to circumcenter of a triangle. So change the name of it to circumcenter of a triangle. And this theorem says that the circumcenter of a triangle is equidistant from the vertices of the triangle. This theorem is made possible because of what other theorem? This theorem only works because of what else, Nicole? The perpendicular bisector theorem, very good, which says what? Very good. Any point that falls on a perpendicular bisector is equidistant from the endpoints of the segment. A circumcenter falls on all three perpendicular bisectors of the triangle. So the circumcenter is equidistant. The circumcenter is equidistant from all the vertices, yes.
So that means if you're going to prove you would need the perpendicular lines theorem before, perpendicular bisector theorem before this one?
Good question, no. No, you would not need to use the perpendicular bisector theorem before this one. You could go straight to saying that PA equals PC equals PB, circumcenter of a triangle.
Does that mean we're not going to use other one, perpendicular bisector?
No, we probably won't be using that one very much. We needed that one, though, to get this one. Because really what we want to know is we want to know stuff about the circumcenter. Okay? So, what's a perpendicular bisector, Alexis? That what, I'm sorry, intersects what? Okay, intersects a segment at its midpoint, and it's perpendicular to the segment. So it's a perpendicular line, ray, or segment. It's a line, ray, or segment that is perpendicular to a segment at its midpoint. All the points on a perpendicular bisector are what? Sarah? No. Very good. All the points on a perpendicular bisector are equidistant to the endpoints of the segment. Now, one point in particular falls on a perpendicular bisector is what, Amber? What point in particular falls on a perpendicular bisector? On a midpoint. Not the answer I'm looking for. What point falls on a perpendicular bisector? On what? The circumcenter, very good. What is a circumcenter? What is a circumcenter? Yes, Edmund. It's the point of concurrency for the three perpendicular bisectors of a what? Triangle, very good. Without a triangle, do you have a circumcenter, Max? No. Now, since all of the points on a perpendicular bisector are equidistant to the endpoints of the segments, what do we know about the circumcenter of a triangle? What do we know about the circumcenter of a triangle, Molly? It's equidistant to all the vertices of the triangle. Okay, now, Alexis, where else is a circumcenter located? Very good. The circumcenter is the center of a circumscribed circle. So let's go back and define circumscribed circle. So a circumscribed circle is a circle that encloses a polygon. Circumscribed circle is a circle that encloses a polygon. Each vertex of the polygon touches the circle. A circumscribed circle is a circle that encloses a polygon. Yes, Brendan. Of a triangle? Yes. If it's of a triangle, yes. I can't think of a counterexample, so yes. So a circumscribed circle is a circle that encloses a polygon. Each vertex of the polygon touches the circle. So, circumcenter. In terms of a circumscribed circle, where is it located? Dan? In the center, right? A circumcenter is the center of a circumscribed circle. And what type of line does a circumcenter fall on? What type of line does a circumcenter fall on? Kellen? A perpendicular bisector. Very good. Here's my question to you, and I want you to answer this. You can answer this on the bottom of the page. In terms of a circumscribed circle, what is a perpendicular bisector? In terms of a circumscribed circle, what is a perpendicular bisector? And I'll throw this up there, of a triangle. In terms of a circumscribed circle, what is a perpendicular bisector of a triangle? Answer at the bottom of the page, please. Okay, so I set you guys up with questions to help you come to this realization. Let's go back to those questions. Where does a circumcenter fall in terms of a circumscribed circle? Maureen? The center. So, the circumcenter is in the center of a circumscribed circle. Keep that up there. Now, what type of line does a circumcenter fall on? Lauren? A perpendicular bisector. That means the perpendicular bisector goes through the circumcenter, and the circumcenter is what, Keegan? The what? The, I've said this a few times. No.
I said center.
What type of circle?
Oh.
So, the perpendicular bisector goes to the circumcenter, which is the center of a circumscribed circle. What type of line would go through the center of a circle? What type of line goes to the center of a circle, Tyler? The diameter. The perpendicular bisector of a triangle is the diameter of a circumscribed circle, yes.
I was just looking at pictures. On any right triangle, would the circumcenter be on the hypotenuse?
Yes, I'm going to go through that, yep. Molly, question. Okay. So, in terms of a circumscribed circle, the perpendicular bisector is going to be the diameter of the circumscribed circle. Now, the circumcenter itself is always the center of a circumscribed circle. It's always going to be the center of that circle. But in terms of triangles, it can change locations. If you look at the pictures right at the bottom of that page, it says location of the circumcenter. For an acute triangle, the circumcenter will always be located on the inside of the triangle. The circumcenter will always be on the inside of the triangle. For a right triangle, the circumcenter will always be on the triangle. And I'm going to get a little bit more specific with you. Where is it on the right triangle? Where is it on the right triangle? Pierce. On the hypotenuse. Very good. So it's on the hypotenuse. I think I know what you're going to say. In an obtuse triangle, the circumcenter is located outside of the triangle. Now, I want to go back to that right triangle, and I want to get more specific than just the hypotenuse. Where is it located at on the hypotenuse? Claire. On the midpoint. Why is it on the midpoint? How do you know that it's on the midpoint? Because it looks like it? Or how do we know that it's on the midpoint, Brendan? Sarah. Very good. One of these is the perpendicular bisector of the hypotenuse. I believe that's what Brendan was trying to say. This line right here is the perpendicular bisector of the hypotenuse, which means that it's intersecting it there, so that has to be the midpoint of the hypotenuse. Okay? That's one way you could have recognized it. Keep in mind that the circumcenter is what with the vertices? What is the circumcenter with the vertices? Yeah. Edmund, sorry. It's equidistant from the vertices, right? So if the circumcenter is equidistant from the vertices, then the distance from here to here is the same as from here to here. So that has to be the midpoint also, because it's equidistant to the vertices. Look at this right triangle. What is the hypotenuse in terms of the circumscribed circle? What is the hypotenuse in terms of the circle there? Pierce. The diameter. Very good. So, in a right triangle, the hypotenuse is also the diameter. Hypotenuse is the diameter. In terms of a circumscribed circle, the circumcenter is always where, Nicole? In the center. For a triangle, the circumcenter can change its location. For an acute triangle, it's inside. For a right triangle, it's on the hypotenuse. It's on the midpoint of the hypotenuse. And for the obtuse triangle, it's located outside of the triangle. My question to you is, regardless, for any type of triangle, it doesn't matter if it's acute, right, or obtuse. For any type of triangle, the circumcenter is always located where? Now, I just got done telling you, for an acute, it's inside. For the right triangle, it's on the hypotenuse. And for the obtuse triangle, it's outside. But what I'm also telling you is that for any type of triangle, the circumcenter is also going to be located in this one position. Even if it's obtuse, it'll be outside, acute, inside, it doesn't matter. Because its circumcenter is always going to be located in this one spot. If I look at a triangle, I can say, that's the circumcenter because it's located here. Pierce. Nope, not in terms of the circle. Forget the circle. Circle isn't there. That's what you're going to say, the circle. Forget the circle. I want it in terms of the triangle. The point of concurrency of the three perpendicular bisectors, good, but not what I'm looking for. Lauren. Nope, doesn't have to do with the hypotenuse. It could be any type of triangle. Right triangle, acute, obtuse, it doesn't matter. The circumcenter is always located in this spot for any type of triangle. It doesn't matter. Keegan. No, 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 no. Maureen. No, because for an obtuse, it's outside, and for an acute, it's inside, so it's not the center of a triangle. Tyler.
These lines that cross.
Those are perpendicular bisectors.
It's the point where they intersect.
That's the circumcenter, where they all intersect, yes. What? No. This is something we just studied today, and I've asked you about it probably 2 or 3 times this period. Now I'm just asking it to you in a different format. Alexis. Yes. For any type of triangle, the circumcenter is always going to be equidistant to the vertices. So, write this down. You can write it underneath that theorem 5.4 because it ties right into that. Right underneath this theorem here, write it down. For any type of triangle, the circumcenter is always located, for any type of triangle, the circumcenter is always located equidistant from the vertices of the triangle. There's a lot of stuff to take in here, a lot of different concepts to take in. Going back. Now, these red lines here, I didn't say this earlier, but just in case you didn't recognize it, these red lines, what do these red lines represent in these diagrams here? What are these red lines here? They're all the what, Edmund? They're all the perpendicular bisectors, okay? P is the circumcenter here and all this and all of these here. Now, jumping back, perpendicular bisector is what in terms of the circle? In terms of the circle, what is the perpendicular bisector, Kara? The diameter. In terms of the circle, what is the distance from the circumcenter to each vertice? In terms of these three circles, what is the distance from the circumcenter to each vertex? Max? The radius. Yes. The distance from P to each vertex is the radius of the circle. The distance from the circumcenter to the vertex, or the vertices of triangle, is the radius of the circle. The distance from the circumcenter to the vertices of the triangle is the radius of the circle. The distance from the circumcenter to the vertices of the triangle is the radius of the circle. Andy. No. The circumcenter is always in a circumscribed circle. That's always the center of a circumscribed circle. And the circumcenter happens with a triangle whenever you have three perpendicular bisectors. Does that make sense? Does that answer your question? Not necessarily, no. No, it's just these two concepts are related. A circumscribed circle could also have a square in it. It's any polygon could be in there. It could be a pentagon, whatever. It doesn't have to have a triangle in it necessarily. Okay, I'm going to stop there for today. Your assignment for tonight, 5.2b, numbers 1 to 18. 5.2b, numbers 1 to 18. Have a good day. I'll see you tomorrow.